All right, I want to take a look at a first example of a triple integral just to kind of get this feel of how do we do it with more variables in our equation. But it's the same idea that we worked with before, where anything except the variable that you're integrating with respect to, we're just going to treat as a constant. So let's take a look at this example. So we've got the integral from 0 to 2, the integral from 0 to x, and then 0 to x plus y of xy plus 3xz. And we're going to do dz, dy, dx. So notice first we're going to do dz, and when I do the integral dz, what we're going to do is we're going to integrate, and anything that's an x or a y, therefore, we'll just treat like a constant. So something like xy is really just one big constant. So when we integrate with respect to z, it would become xyz. And then here, I've got plus 3xz, and when we take a look at that, it's really just a constant times z, so we'll keep the 3x, and then z is going to increase in power to a 2, and then we divide by the new power, so we're really left with 3 halves xz squared. And so now what we're going to do is we're going to plug the bounds in of 0 to x plus y, and this is still dy dx. So now we've got the integral from 0 to 2, the integral from 0 to x. So remember, careful, we're plugging these in. This was a dz integral, so we're only plugging these bounds into z's, which kind of makes sense. We're not going to plug in x's and y's into x's and y's. You're going to plug it into the other variable. So we're going to end up with x y times x plus y, and then we'll have 3 halves x times x plus y squared. And then if I plug in 0, well, here we would just get xy times 0, which is 0, and then 3 halves x times 0, which is 0, so we don't get anything from the bound of 0. So then we have dy dx. Taking a look at this now, we need to simplify this algebraically in order to take the integral. So on the first piece, we need to distribute. So we'll have the integral from 0 to 2, the integral from 0 to x. We'll have x squared y plus xy squared. Here, we can write it in 2 steps, or we can try and be clever and write it all in one. So think about the idea that x plus y quantity squared is really x squared plus 2xy plus y squared, because we would distribute it out. And then now I can distribute the 3 halves x, so I'm going to have plus 3 halves. We'll have x times x squared is x cubed. We'll have plus 2 times 3 halves will just be 3, and then we'll have x squared y, and we'll have 3 halves xy squared. And then this will be dy dx. So we're going to take a look at this. Next, do the dy integration, so then we'll end up with 0 to 2. The first one, we've got x squared y, so remember x is our constant, so we'll really keep the x squared. Y will increase to a y squared, and we divide by the new power, so that will really be 1/2 x squared y squared, and then we'll have plus a third xy cubed. And then notice that 3 halves x cubed doesn't have a y at all, so that whole thing is a constant, so we have plus 3 halves x cubed y. And then we're going to have plus 3x squared, the y will bump up to a y squared, and we'll divide by 2, so we'll get 3 halves x squared y squared. If we had been clever, we could have combined these in the first place. Notice we have x squared y multiple times in here. We also have x y squared multiple times in here. So I'll combine them after this before we plug in. So we've got plus here, we got to increase let's see, that's where I'm at, right? Yes. So we've got 3/2 xy squared. So we're going to increase. This will be xy cubed, and we'll be dividing the 3/2 by 3, which just leaves me with a 1/2. Which, why don't I go ahead and just write that in line with the other part, so plus 1/2 xy cubed. And then this is going to be evaluated, we've got from 0 to x. And we'll do this whole thing dx. So quick, before I plug it in, let's do that simplification that I just mentioned. Right, we've got some like terms. I've got an x squared y squared here, and then another x squared y squared, so I have a 1/2 plus 3/2 would be 4/2, which is 2. So we've got 2x squared y squared. And then my xy cubed, I have a 1/3, and I have another 1/2. So if we put those both in terms of 6, I have 2 6 and 3, which would make 5. So we have 5 over 6 xy cubed. So that took care of, we took care of those squares and then the xy cubes. So then I'm left with a plus 3/2 x cubed y, and we're going to evaluate that from 0 to x dx. So we need to plug in x's now to the y's. So we're going to get 0 to 2. So we'll really have 2x to the 4th, and then we'll have plus 5/6, again x to the 4th, and then 3/2, again x to the 4th. So it's just x to the 4th in all different ways. And then notice if I plug in 0 to all the y's, we just get minus 0. So let's combine all of these, see how we can do our little mental arithmetic. So we've got 2 and 3/2. So I can, actually let's just put everything in terms of sixths. So 2 would be 12/6, 3/2 would be 9/6. So we've got 12 and 5 makes 17, and then with a 9 would be 26. Let's see, let me add it a different way and make sure that we got the same thing. Yeah, because 12 and 9 would be 21, and then 5 would make 26. Which then we can subtract a 2 if we want, so really we could reduce that to 13/3. And then this was all x to the 4th. And this is dx. So now we've just got a little power rule to do for our last one. So we'll end up with 13 over that power of x is going to go up to a 5. And then we would divide by that 5. It'll multiply by the 3 to give me 15. And then we'll do this from 0 to 2. So plugging in that 2 gives me let's see, 2 to the 5th is 32. So we have 13 times 32 all over 15, which I need to break out a calculator quick to see what that's going to be. Let's see, 13 times 32 is 416. So we would have 416 over 15 at the end. So kind of the main thing to take away, right, is we're taking a look at what, every time we do an integral, what's constant and what is our integration variable. So just kind of taking it one step at a time and remembering those integration rules as we go. Here, I'll let you be able to see our end work over there. So notice this isn't an example of volume, it's just simply a straight, I gave you a triple integral and we evaluated it.